This is trigonometry, day 11. We're going to start with this warm-up, just to review some of the vocabulary that we've been talking about. You can just do this along with me, starting with when they give us a function to find the amplitude, the frequency, the period, and the range, just to review that. So the amplitude of this function, remember, corresponds to this coefficient that's out in front. Amplitude is always positive, so it's the absolute value of whatever that coefficient is. So the absolute value of -2 is 2, so the amplitude of that function we would say is 2. The frequency is the b value. That's the number in front of the x. That tells you the number of cycles in between 0 and 2 pi. So it's a little bit strange in this one because it's not a number, but there would be pi cycles in between 0 and 2 pi. That's all right. It happens sometimes. The period is the length of one cycle. So if you have the frequency, you can calculate the period by doing 2 pi divided by that frequency. So we would get 2 pi divided by pi, which would give us 2. So the length of one cycle of that graph would be 2. And then finally the range, right, which we get from the amplitude. If the amplitude is 2, then that means the range goes from -2 to 2. So just refreshing our memory on some of those concepts from the other day. And then if they give us a graph and they want us to come up with the equation, and a couple of things to consider, right? Is it a sine graph or is it a cosine graph? That depends on where it starts. So this graph starts at 0, which means that it's a sine curve. Okay, so it's a sine curve, goes up to 3, down to -3, so that's the amplitude. Right? It's not reflected, so we don't have to put a negative in there. Reflected. The other thing to work into the equation is the frequency. Now the frequency is the number of cycles between 0 and 2 pi. However, what's strange about this is there's no pi's on this axis. Right, so how many cycles are between 0 and 2 pi? I don't know. I can't tell from looking at the graph. I can, however, figure out the length of one cycle. Because if I notice, one cycle of this sine curve, right, goes from 0 to 1. So that's actually the period. So although we normally go from the frequency and find the period off of that, we can also go the other direction. If we have the period, we can find the frequency. And I know we didn't quite get to this at the end of day 10 there, and there was a question on the homework about it. I think it was the first one. So normally you have the frequency to find the period. However, you can also go the other direction. So if I know the period, I can then use that to find the frequency, because then 2 pi over b must equal 1. And then I can use that to solve for b. So if I multiply both sides by that denominator and that crosses out, right, I get that frequency is equal to 2 pi. Again, a little strange because we're used to seeing a number there, but that happens sometimes. So we could put that all together, and then we would get 3 sine 2 pi x. That's the equation that goes along with that graph. You could check it on your calculator, match the window, match the mode, but that's how you would put that together. Then wanted to talk about this going from the period to the frequency, because that's going to come up again. Okay, so on to our notes here. Just going to change my view, pardon me, get a little bit bigger. Okay, so last class we talked about amplitude, frequency, and period. Today we're going to focus on the midline and the phase shift. So a quick review up here, and here's our general forms. Right, we've discussed the effects of A, which is our amplitude, right, and B, which is the frequency. This is a vertical dilation, this is a horizontal dilation, affects the number of cycles. Okay, so today we're going to look at C and D. So we're going to start with this example here. Consider the function f of x equals sine of x plus 3. How would the graph of y equals sine x be shifted to produce the graph of f of x? So just based on our knowledge of transformations from before, when we have a number adding on to the outside of our function, that adds on the outside, it affects the y value. So if I'm adding 3 to my y value, that's going to translate it up. All right, so translate up 3. So then it says on the grid to the right is the basic sine curve. So we can see that here. Again, normally we see it from 0 to 2 pi. They added on another cycle here. But that is sine x. So then if I want to sketch this f of x that's been translated up 3, right, I can basically take each of these points, right, starting here, and then pull them up 3. So this one that was over here at negative 2 pi 0 is up 3, right, taking all of these points and just shifting them up 3. And so that's going to take my sine curve and actually boost it up 3. Okay, continuing on over here, pulling that one up 3, pulling that one up 3, pulling that one up 3, and then pulling that one up 3. Okay, so all these points got pulled up 3. Now we can connect the dots. There's one curve. And then there's the other curve. Okay. And then it says, on the graph that you sketched, draw the horizontal line that splits the graph in half. What is the equation of that line? So we can see, and there's still this line that goes through the middle of the graph. All right, so what is the equation of that line there? It's a horizontal line, and it crosses at y equals 3. Okay. Oops, and good morning. So that's not a coincidence, all right, that got moved up 3. That line that we drew there, that's the midline, and some people also call it the wrap line, because the graph wraps around it, but I tend to call it the midline. So it's the midline of the sinusoidal graph. We'll start seeing this word sinusoidal to describe sine curves and cosine curves. So it's always equal to the vertical translation. Always equal to the vertical translation of the graph. It is also referred to as the average value of the function and can be calculated by taking the maximum value, adding the minimum value, and dividing it by 2. And because that line goes right through the middle of the graph there, and it's basically the average between the high point and the low point. So you can calculate where that midline will be, if you don't happen to know it offhand, by doing that, max plus min divided by 2. And amplitude is max minus min divided by 2. Midline is max plus min divided by 2. So that comes in handy sometimes, is knowing how to do that calculation. Okay, so let's put this to work with a function. There's a little kooky there. Okay, so 2 cosine x plus 1. So state the amplitude, frequency, and period. So nothing new about that. All right, looking at our equation, amplitude is the absolute value of that coefficient that's out in front. So the absolute value of 2 is equal to 2. All right, frequency is the value in front of the x, which is 1 in this case, so 1 cycle between 0 and 2 pi. And then the period is the length of one of those cycles. So 2 pi divided by b. So 2 pi over 1 is just 2 pi. Okay. So now we've got an additional question. It says, what's the midline of f of x? So I would look at this and say, oh, there's a plus 1 on the end. I've got a vertical translation of 1. All right, so if we translated it up 1, translate up 1, right, that means the equation of that midline is going to be at y equals 1. Okay, so it's always equal to y equals whatever that translation is. Okay, then we want to sketch a graph between negative 2 pi and 2 pi. So, you know, sometimes they say sketch 1 cycle, sometimes they give you a particular domain. Okay, so this is actually not just 1 cycle, because 1 cycle would just be from 0 to 2 pi, so just be aware of that. So we'll work that in over here. The other thing is that we're going to add on that's new is when we're sketching our trig functions, the key to getting it in the right spot is to graph that midline first. And so we're going to start doing that when we graph our trig functions. Okay, let's get our axis set up over here. So one cycle goes from 0 to 2 pi, so I'm going to put the normal quadrantals on here. Pi over 2, pi, 3 pi over 2, and 2 pi. And then I'm going to go out the other side. Negative pi, negative 3 pi over 2, negative 2 pi. The amplitude I notice is 2 when I'm thinking about the y-axis, right? But then it's also going to have this +1 translation, but I've got enough room for that, so that's fine. I am going to consider my parent function. Right? So the parent function, again, for both sine and cosine, it always has 5 points. So we got the 0 and our 4 quadrantals. Right? Cosine starts up at 1, and then we go to 0, and then to -1, and then to 0, and then back up to 1. Oops. Slightly off center there, sorry. Here's our regular cosine graph. Okay, the difference is this one now, because I have this vertical translation, and before I start putting points on my graph, I'm going to sketch my midline on there first. So I'm going to put a line across at y equals 1. I'm going to dot that in there. So now when I go to put the points on of my cosine curve, and then let's just focus on the 0 to 2 pi part first. It's a little bit easier, right? So normally the cosine graph would start high, right? So it would start up at 1. It's the amplitude distance away from the midline. Now this one has an amplitude of 2, right? So I need to get 2 away from the midline, and the midline's not the axis anymore. It's actually at this line, y equals 1. So the first point on this cosine graph has to be 2 above where the midline is. Okay, so that's my starting point up there. Okay, so 2 above the midline because the amplitude is 2. Then I'm going to proceed on with the cosine pattern. The next point would normally go down at 0, but that's really because it's on the midline. So the next point on the cosine graph is going to be here. And so that midline is like the anchor for the graph. Okay, then we go to the minimum, right, which is whatever the amplitude is below the midline, and my amplitude is 2. So this point here has to be 2 below this midline. So we're going to put a point there. Then we go back to the midline. Okay, and then we finish high in 2 above the midline, so that final point in that cosine graph would be there. Okay, so I've worked that vertical translation in addition to the amplitude, right? And that's one cycle of the cosine curve. Okay, now technically this did say to graph from 0 to 2 pi, so if I want to extend this, right, I would just keep this pattern going out the other side. So there would be a point there, and then a point down there, 2 below the midline, and then I would go back to the midline, and then I would finish up here. Okay, so there's the other part of that cosine cycle there. Okay, then graphing the midline first and using that to anchor the graph, that's the new piece of this. Okay, so then it says what's the range of the graph, right? I mean, we can look right at it and see that it's -1 to 3, right? That comes from, if we look at the equation, if the amplitude is 2, right, the range would have been from -2 to 2. But then we had this vertical translation of +1. So if we add 1 onto both endpoints there, right, we're going to end up with a range going from -1 to 3, which is what we have and from the graph. But that's how you can calculate it from the equation. It matches up like that. Yeah, so working this midline and is our big job of the day here. Okay, flipping the page. So I see in the last example, the vertical translation along with the amplitude affects the range of sinusoidal graphs. So we'll have to work that in. Okay, so like we've seen before, now here they're just giving us a couple of functions, and they want us to go through and find all the important information. So we can work through there. So for Roman numeral 1, the 7 sine 2x plus 4. Right, so starting with the amplitude, and that's the absolute value of whatever that coefficient is. So the absolute value of 7 would be 7 for the amplitude. All right, frequency is the number in front of the x. So the frequency is going to be 2 cycles in between 0 and 2 pi. Okay, calculate the period. 2 pi divided by the frequency. Now we could set that equal to b so we don't get confused. Okay, 2 pi divided by 2. So the period is going to be pi. Okay, the midline, right, is this vertical translation. So I've got a vertical translation of plus 4. So that means my midline is going to be at y equals 4. And then finally, to calculate the range, and I start with the amplitude. So if the amplitude is 7, it would be from -7 to 7. But then I have to work in this vertical translation. So I would add 4 to both endpoints there. So the range is going to end up being from -3 to 11 when all is said and done. Okay, and then we can do a similar thing for Roman numeral 2 here. And working through with our cosine graph. So amplitude, now this one has a negative, right? But remember, amplitude is always positive because technically it's the distance to that midline. Okay, so if we were to graph this, it would be reflected. That's what that negative tells us. But the amplitude itself is positive. So amplitude is +5. Frequency is the b value, which is pi over 3. Period is 2 pi divided by the frequency. Okay, so we've seen this, and sometimes we get these complex fractions when you do 2 pi divided by pi over 3. So, and if you multiply by that denominator, cancel those out there, right? You end up getting 6 pi over pi, and those pi's would cancel out, and you would just get 6. So the period of that one would be 6. Okay, and then new today is the midline. So I look to see where that vertical translation is, and here it's at -6. Okay, so we've got a midline at y equals -6. And then finally we can figure out the range, right? So if the amplitude is 5, it would go from -5 to 5, and then we have to translate it down 6. Oops. So I got to subtract 6 from both ends there. That would be -11 to -1 for the range. So just being able to calculate all that information based on the equation. Okay, and then we're going to sketch out a graph ourselves. And so basically finding all that information and then putting it together to make a sketch. Okay, so we're going to sketch this graph for one complete cycle. So we're going to find most of this important information and then turn it into our graph. So starting with the amplitude. Right, so the amplitude is the absolute value of -3. So it's 3, right? But it's got that negative, right? Which means there's a reflection happening. And so when I graph this cosine graph, it's going to be upside down. Okay, to help me set up the x-axis, I'm going to start by finding the frequency, which then leads me to the period. So 2 pi divided by the frequency. So 2 pi divided by 2 would be pi. So again, that's how I know how to set up my x-axis, because one cycle of this graph is pi long. So when I set up my axis in a second, I'll use that. Okay, to help me set up my y-axis, I'm going to look for the midline, and also to help with the graph. And so the midline is going to be y equals 1. And when I sketch my graph, I'm going to sketch that midline first. And then we can calculate the range just to make sure we do everything correctly. And so it would go from -3 to 3 based on the amplitude. Then if I translate it up 1, it would go from -2 to 4. Okay, so when we get our graph, we should check that the range goes from -2 to 4, and it should match that. Okay, again, I'm going to base it on my parent function. It's cosine. They're not evenly spaced at all, sorry. But again, for cosine, starts at 1, right? 0, -1, 0, back to 1. And so that's our parent graph. But then I'm going to work these transformations in. So we're going to set up our axis here. draw this line. Okay, pretend that's a straight line, sorry. Maybe I'll redraw it. Okay, you guys know how I am about drawing straight lines. There we go. Okay, so on our x-axis, right, we've got it. We want to put our 5 points. This counts as 1. Again, skip a couple of squares. Let's say I do 1, 2, 3, 4. If one cycle is pi long, again, that means I'm going to label that last one as pi. And if you want to go through and figure out what these are, you can. Half of pi is pi over 4, so you're really counting up by pi over 4, but it doesn't matter. Okay, as long as you have this ending value marked there, that'll be fine. Okay, then I'm going to set up my y-axis. Again, skip squares if you want. And just put some hash marks on there. Just watch your counting, since we're skipping squares here and we're not skipping them here. Okay, and then before I put my points on, and I'm going to start by putting the midline on there first. And so that's the anchor line. So I'm going to dot in a line at y equals 1. And so I'm going to use that as the basis for my graph. Okay, so it's a cosine graph. All right, so the first point of the cosine graph would normally start high. All right, this one's got an amplitude of 3. It's also been reflected, so it's actually going to start below the midline. And because the amplitude is 3, we're going to start 3 below the midline. Okay, so the first point in that cosine graph is going to be down there. Okay. Then the next point in the cosine cycle, again, goes to the midline. So this point's going to be right there. Then the next point in the cosine graph is, below the midline, except reflected, so we're going to be above the midline. And the amplitude is 3. So now I'm going to go up 3 above my midline. Okay, then I go back to the midline. And then I finish at 3 below the midline. Okay, and now I have a nice upside down cosine graph. Right, we can see the range goes from -2 to 4 as we anticipated. Okay, so that all matches. Again, you can check this on your calculator. Right, just match the window. Make sure it's in radian mode, match the window, and you can see that you've done that graph correctly. You can check that. Okay, probably should have labeled our y-axis too. Wouldn't be a bad idea to do that. Okay, we can mark those on there. Okay, and then we've got another example where they give us the graph and they want us to come up with the equation. Okay, what's weird about this is, it looks a little off center, right? Because the midline is not the x-axis anymore, right? So to try to figure out whether it's sine or cosine, we actually kind of need to know where that midline is. And you can sort of guesstimate what's going on based on the symmetry, but the nice thing about the midline is you can actually calculate exactly where it is. Okay, so because it's the average value between the max and the min, right? So I'm going to actually start by calculating where that midline is. So the maximum value of this function is 3, right? And then the minimum is -1. And so if we take 3 plus 1, or -1 and divide it by 2, right? 2 divided by 2 gives us 1. So that means the midline is at y equals 1. Now if we dot that in there, we can get a better sense of what's going on. Because now I can say, oh, okay, this graph starts at 0, right? So it's a sine graph. However, it is upside down, right? Because normally a sine curve should go up and then down. And so it has been reflected. So there will be a negative that we need to work in there. Once I know where that midline is, and I can notice the amplitude, right? And the amplitude is the distance from that maximum point to the midline, and also from the minimum point to the midline, right? It should be the same for both, and it's a distance of 2 for both. Again, you could also calculate that by doing max minus min divided by 2. Right? 3 minus -1 divided by 2, you get 2. Okay, so other ways you can figure that out. Okay, and then finally we need to know the frequency. Right? I can see because of the way they mark this axis from 0 to 2 pi, right, in between 0 to 2 pi, I do see exactly one cycle of the sine curve there. So that means that the frequency is just equal to 1, and I can figure that out from the graph. Okay, and then putting that all together to make our equation. The negative's got to go out in front for the reflection. Oops, except it's 2, sorry. Negative 2 sine, and that our frequency was just 1, x. And then don't forget this midline, right? We have this vertical translation, so then we've got to put the plus 1 on the end. Okay, so negative 2 sine x plus 1 should be the equation of that. Again, you can check it on your calculator just to confirm. Okay, so we've been spending a lot of time on the midline, which is the d value. Right? This last little bit here just talks about the c value, which is the phase shift. Thankfully, you normally don't have to do too much with this other than just identify it when it's happening. So the phase shift is just another name for a horizontal translation. We know the horizontal translation comes from adding or subtracting something to the x value. That's really messy, sorry. Small line, horizontal translation. Okay, so basically we just need to notice, it's the c value in that function, so just need to notice that there's a horizontal translation going on. So they're just giving us two functions here, right? And if we run through all the important information, you'll notice it's basically the same for both of them, right? Like they both have an amplitude of 3 out in front. Inside the parentheses, although it looks a little bit different, right? They both have a frequency of 2. That's the value in front of the x. Right? If the frequency is 2, then that means the period is going to be 2 pi divided by 2, right? Which is just pi. They both have a midline at y equals -1. And then the place where they differ is this phase shift, right? Because inside here, I don't have anything going on. Nothing adding or subtracting to the x value, so there's no phase shift in here. Inside this one, however, I have this minus pi over 2. So, and think about what we know for horizontal translations from our past life. Anything that affects the x value is written backwards, right? So when it says x minus pi over 2, it really means you're supposed to go pi over 2 to the right. Okay, so just to identify that that is what is happening there, that that one has a phase shift. And then if we wanted to sketch one cycle quickly, we have this pre-made axis. And it's a little bit strange because one cycle is only pi long, so we have to kind of squeeze them in here, but we can do it. And a sine curve, going back to our parent function, 5 points for the sine curve, starts at 0. So 1, 2, 3, 4, 5. Right, there's our basic sine curve. Okay, so if I want to graph this 3 sine 2x minus 1, remember we've got to put the midline on there first. Right, they both have a midline at -1. So we're going to dot that in there. Okay, and then sine curve starts at 0, so it would start on the midline. And again, I've got to squish this in between 0 and pi. So I'm going to kind of break this up into my other so I can get my 5 points on there. So it'll go like that. Okay, so sine starts at the midline, right? Then it goes above the midline, and this one has an amplitude of 3. So the next point in the sine graph would be 3 above the midline. So 1, 2, 3, that would be there. Okay, then I go back to the midline. Then I go 3 below the midline, which would put me down there, and then I finish. Did I count wrong? Oh yeah, sorry, got to be one more further down. 3 below the midline. 1, 2, 3 would be down there. Okay, and then it finishes here at the midline. Okay, again, a little strange because we're trying to squeeze it into that small space there, right? But that's f of x. And then if we wanted to graph this g of x, that has this horizontal translation to the right, right, we can just take each of these points and pull them to the right pi over 2 units. So this point that was here would really be here, or g of x. And this point that was here, if I move it pi over 2 to the right, right, it's going to go here. This one that was here is really here now. Circle these. This one that was here is really over here now. And then this last one that was here would move pi over 2 units to the right, and it would be here. And so just taking those points and moving them pi over 2 units to the right. There's g of x. That's about all you need to do in terms of phase shift, is just to identify that it's happening. And if you wanted to work it into a graph, that's how we would do that. Okay, and that is the end of trigonometry day 11.